I really enjoy for loops. I just really like to use them, and I'm finding out they're more powerful than I ever realized. You can use them as while loops for the most part, with very limited issues. But for the most part, I use for loops when I have a definite number of iterations I want to use. A for loop allows us to put everything in one little box. There are 3 statements in one statement. There's the loop control variable, declaration, and assignment. There's the test condition, and then there's the expression that alters the loop control variable. In the loop control variable you see here, we have value is assigned 1, value is less than 11, and we're going to prefix our value. So we're going to add 1 basically before we even step in anywhere. Not that in this case it would matter if we prefix or postfix, because the variable is not called until we're in the body of the loop. Alright, but this is going to run 1 through 10 and then exit when we get to 11. So this is going to print 1 through 10, and then the while loop is going to do the same thing. And so for loops pretty much just simplify. You have 3 statements in the while loop that are embodied in one little for structure. And you can see that this value equals 1 is put inside the for loop. Value is less than 11 is put inside the for loop. And plus plus value is put inside the for loop. So it's a simplification. Now those are conventional loops. There's also unconventional loops. For example, we can initialize more than one variable. If we do that, we're going to place commas between separate statements, and we can do the performance of more than one test using and or operators. We can decrement or perform some other test, and we can alter more than one variable. Also, we can leave one or more portions of a for loop empty. Let's step into some code and see how a for loop might work with 2 variables. Okay, so here's a very basic program where we've actually set up 2 variables within the for loop. And in this case, I'm going to take I is equal to 1, j is equal to 20, and as long as I is less than 500, we're going to keep running the loop, and we're going to just take I and multiply it by j and reassign it back to I. So it's very, very basic, but I just wanted to show you guys that that it is possible to run two variables within the loop. And let's run this program, and you can see what it does. So I starts at 1, j is at 20, 1 times 20 is 20, reassign back to I, j is still 20. Now 20 times 20 is 400, j is still 20, 400 times 20 is 8,000, the loop exits, and we don't see those variables again. So that's a non-conventional loop, but it does function. I'll show you guys 2 quick ways to pause a program if you need to pause a program. One is by using a no body loop, right? And I'll show that to you real quick. So we're going to bounce back into the same program, but every time we run the program, we're going to use a value called k. We are going to set k equal to 0. We're going to say as long as k is less than 25,000, right? We're going to keep adding 1 to k. And that's going to give you a little bit of a pause between each line of this code running. I'm going to save this and compile it, and then we're going to, what did I do? For k is, int k. Int k, save that. We're going to compile it now. Alright. And didn't see much of a pause, so we'll do 250,000. Alright, we're gonna compile it again. Still not much of a pause, so let's make this a long and just add a couple extra zeros here, looking for a pause, right? Alright. Alright, and more zeros. We're gonna get a pause eventually. Alright. Oh, I need to put that L at the end, set that up as long. Okay. Java C. I think you're going to see a pause this time. There you go. See that pause? Okay. Just has to do with how fast your computer is running. There's a more accurate way of pausing it, and that is using an actual sleep. And I'm going to show that as well. I realized I had the wrong screen showing, so I'm going to go ahead and turn the right screen on, and I'm going to show you guys that code running again, so you can see that we do use the really long number to do this loop counter, right? And that's going to look like this. We're going to compile it, and then we're going to run it, and you can see it's pausing between each iteration of the loop. The more efficient way of doing this without typing those long numbers is by inserting a thread.sleep command. And I'll show that here. It's thread.sleep, and thread.sleep runs with milliseconds. So we're going to put 2000 here. Be aware that this does throw an interrupted argument or interrupted exception. And I'm going to redact this by using a comment of code. And what I expect it to do is actually give me a compile error because of that exception. We'll see what happens when you run it. Well, it actually worked this time. So you can see there's a 2-second delay between each of these using the thread.sleep, and to me that's a more efficient and accurate way of running this function. So yeah, thread.sleep works really well. Alright, and that kind of covers what you need to know about for loops, so we're going to stop the recording here.